Today, we'll investigate how perspective projection works and practice sketching a few simple objects based on the projection method. The perspective projection is frequently used in pictorial sketches. Pictorial sketches are made to show the overall shapes of the objects by visualizing multiple sides of the objects in one view. There are three view directions that are typically used in CAD systems: trimetric, dimetric, and isometric. We'll discuss more about the isometric view directions in a later class. The perspective projection works similarly to the way how you see things through your eyes. Cameras also work similarly. The image of an object is focused and formed on the retina in your eye upside down. Your brain processes the upside down image along with a lot of more complicated processes going on in your eyes and brain. We can simplify it by setting up a transparent plane in front of your eyes, and you can see an object through the plane. If you connect a line between your eye and a point on the object, the intersection point of the line of sight with a plane is the image of the particular point of the object. This is illustrated in the figure on the right. Depending on the location of the object relative to your eyes, the image of the object on the plane can be large or small. Obviously, if the object is close to the image of the plane, the projected image will be large. When the object is far away from the image plane, the formed image on the plane will be small. In the perspective projection, an object that is far away looks smaller than it is, whereas an object closer to your eyes looks larger. The plane looks smaller than it is in the picture on the left. The railroad seems to converge to a point at the far end while they are parallel to each other. These size changes based on spatial locations give you a depth perception to your eyes, so you can perceive the 3D space. If you take a picture of a building, although the picture is a flat 2D image, you can perceive the depth and the building looks realistic in a real three-dimensional space. This is because the size changes depending on how far the objects are from your eyes, and your brain is trained to process it accordingly. So, a perspective view gives a good realistic view of an object, but a downside is that it is hard to measure the size of an object by measuring the picture. You can measure the length of the window of the building from the picture, but to know its actual size, you also need to know how far your camera was from the building when it was taken, as well as many other parameters, and the calculation can be quite complicated. Also, the shape of the object is distorted in the perspective projection. A perspective sketch is good to visualize the overall shape of an object because it looks realistic with a 3D depth perception. But it is not used in engineering drawings because it does not convey the accurate size and shape information independent from its location. In making a perspective sketch, you need to understand the horizon and vanishing points. In sketching an object in the perspective projection method, you need to understand the relationship between your eyes, the horizon, and one or more vanishing points. Let's say you are standing on a railroad and looking straight forward so that your view direction is horizontal parallel to the ground. You can still see the railroad. Imagine a vertical image plane in front of your eyes. If you draw a line from your eye to each point on the railroad, the trails of the intersection points illustrates the railroad image you see in your eyes in that view direction. As you can see, the projected points on the image plane of the two parallel tracks get closer to each other and converge to a point that is on your line of sight. The point is called a vanishing point. Notice that the two railroad tracks are parallel to the view direction, or in other words, perpendicular to the image plane. Any arbitrary line that is perpendicular to the image plane or parallel to your view direction converges to the same vanishing point in the image plane. In general, all lines that are parallel to each other in any arbitrary direction in the space converge to a certain common point on the image plane that may or may not be on the horizon. If you see straight forward and the ground is flat with no mountains, hills, or valleys, there will be a horizon at the level of your eyes. The road in the picture looks like it is converging to a point where your eyes meet the horizon, and the point is the vanishing point. This is because the road is parallel to your view direction or perpendicular to the image plane. In fact, Any straight road on the ground that stretches in any arbitrary direction will vanish to a certain point on the horizon, only it may not be the vanishing point where your eyes meet. If there is a straight road in a different location in the same direction as this road in the picture, however, will converge to the same vanishing point as this road. The elevation of the horizon determines how high or low the object is viewed. The location of the horizon represents the elevation of your eyes. If the horizon is at the lower part of your paper, it means your eye level is close to the ground and the object is higher or taller than you are, as if you're looking up the airplane or a building. This is called worm's eye view. If the horizon is sketched at the upper part of the paper, your eye elevation is tall or high, and you look down the object. This is as if you're flying over and looking down the object. This is called bird's eye view. If the horizon is sketched in the middle of the paper, it is like you're standing and looking straight on. If you're looking at a house, for example, some part of the house is higher than you, but other parts are lower than you. This is called human's eye view. The location of the vanishing point determines the orientation of the object. Consider only one vanishing point for now. The vanishing point is always on the horizon line, as we discussed. If the vanishing point is on the right side of the paper, you can see the right side of the object as illustrated in the picture at the top. If the vanishing point is moved to the left, as in the bottom picture, the other backside of the object is visible. So you need to decide the location of the vanishing point so that a proper side of the object can be viewed. There are a few different types of perspective projection methods. Although there may be an infinite number of vanishing points in making perspective sketches, usually the following three types of perspective sketches are frequently made: 1-point, 2-point, and 3-point perspective projection. We'll look at the 1-point and 2-point projections only.